Okay, guys, so lesson 2.5, unit 2, lesson 5. We're going to talk about graphing proportional relationships. The essential question for this one is, what does the graph of a proportional relationship look like? Now, you're going to have to pay attention here because this is the last lesson of unit 2, and I'm kind of bringing everything together here. And so I'm wrapping everything up, and we're going to look at this very carefully. I'm going to try to go as slow as I can, but at the same time, I don't want to bore you guys. So make sure you're paying attention. Okay, so in example 1, they talked about grams versus a cup, and they were talking about sugar, okay? So, and they're talking about, I think, carbs, but grams of carbs. So what they said is how many grams versus cups. Now, what we have to realize here is that the information they gave us in the example, they had 3 grams for a fourth of a cup, okay? And you have to figure out what the actual unit is. Are we talking about miles per hour, dollars per hour, gallons per minute, that type of thing? In this one, it's grams per cup. And so we need to write it like that, grams per cup. What that helps us do is it helps us to set up our function table, okay, guys? Because we know that it is y over x, and I've talked about that before. It also helps us to figure out how to solve this problem and how to find the unit rate. And so what we do is we do 3 grams per fourth of a cup. We know that every fraction is a division problem. So we do 3 divided by 4, 1/4, sorry, which actually equals 3 times 4, right? Because we keep, change, flip, right? Keep, change, flip. And so we don't divide fractions, we multiply them by the reciprocal, and the reciprocal of 1/4 is 4. So we know that our answer is 12. 3 times 4 is 12. So what we're actually saying here is that in 1 cup, now notice how I did this. So cups is x, right? Grams is y. So cups and grams. I want to find out what the unit rate is, and it means per cup because cups on the bottom, right? Right now what we know is that we have 1/4, and that equals 3. So what we're looking at is, okay, we go through and we multiply by the reciprocal to get this. Okay, multiply by the reciprocal, in other words, 4 over 1. We multiply by 4 here, we get 12. So we know that there's one, for every cup, there are 12 grams. Okay, guys? Now here's the deal. That is our unit rate. It is also our constant of proportionality. That gives us our actual, and I wrote it over here, but I'm going to write it down here instead. That actually gives us our equation for this scenario. It is always y equals something happening to x. And what happens to x, if it's proportional, is the unit rate, which is 12. So this becomes our actual equation or rule of this scenario. Now we have to graph it. Now, this is what they're talking about mostly in this whole scenario, is how do we graph a proportional relationship. Now, the first thing we want to do is we want to ask ourselves, is there a 0-0 scenario here? In other words, if I have 0 cups, do I have 0 grams? Yes, I do. And that means that it's going to go through our origin, or it's going to start here, right here in the middle. The other thing we need to do is we need to graph each one of these. In other words, 1/4 and 3. 1/4 and 3. Okay? Then I'm going to graph the other one, the unit rate. 1 and 12. Now you're going to have to excuse me here because this is pretty long, and so it's not going to look that great, but that's what we're looking for. So a graph that is proportional, first of all, there are 2 rules. It will start at the origin or go through the origin. In other words, it has a 0-0 relationship, and it is a straight line. If it were to go through and be squiggly at all, then it's not proportional. And if it does not start, in fact, I'm going to show you right here. Okay. This is in example 3. Okay. This one is proportional because it starts at the origin and it is a straight line. But this one is not proportional because it does not start at the origin. If you notice, it crosses y-axis at 2. Okay, guys, it does not intersect the origin. Okay, guys. And even if it were like this, of course, it would not be proportional. Or if it went like this, it would not be proportional. Even if it started at the origin and went like this, it would not be proportional. So it has to go through the origin, intersect the origin, and it has to be a straight line. Okay, that's what a proportional graph will look like. Okay, so let's look over here. And we are going to look at a scenario from the quiz. Okay, so here's what we're looking at. This is number 5, quiz number 5. Okay, guys. So what I'm going to do to set this up is I've already created my function table. Now, what they told us is that they were buying shells, okay? And they bought 2 shells for 80 cents. They bought 3 shells for $1.20 and 4 shells for $1.60. And so what I realized is it's dollars per shell is what's going to be my unit rate. So first I'm going to go through and I'm going to put these into my function table, okay? That's going to help me graph it, all right, guys? So in other words, if I have 2 shells, right, because it's y over x, right? So 2 shells, then it is 80 cents. If I have 3 shells, then it is $1.20. Oops, I put $1.40, but I meant $1.20. And if I have 4 shells, then it is $1.60. Now, there are 2 different ways to find out whether this is a proportional relationship. 1, we can graph it, and 2, we can go through and do it by division. Okay, so first of all, let's look at the division, okay, because that's the way we're going to find the unit rate anyway. And so what we do is we do this. We look at every single fraction is actually considered a division problem. That's why I keep on saying that to you guys, okay? So in other words, if I don't even need a calculator for this. I don't know why I'm grabbing it out. If I do 80 cents divided by 2, it would be each shell is 40 cents. That is our unit rate. 40 cents per shell. You guys see that? Now let's see if it tests on each one of these. $1.20 divided by 3, that's 40 cents. $1.60 divided by 4, that's 40 cents. Each one of them would come out to be 40, okay? 40 cents, okay? And if it does, then that means that this is proportional. So already we know it's proportional. But now we're going to go through and we're going to graph it to prove it. In other words, is this a 0-0 scenario? If I don't buy any shells, do I spend any money? No, I don't. So that would make it 0-0. So it is going to intersect the origin. Then let's look. 1 shell is 80 cents. That looks good. 2 shells, is 40 cents. I got to add that on there, right? 1 shell is 40 cents. Okay. 2 shells is 80 cents. 3 shells, $1.20. And 4 shells, $1.60. Now, I'll have to say, I'm kind of going off a little bit, but we already know it's proportional. But this is just a reminder, okay, guys? And because I'm freehanding this, obviously, I'm pretty bad at drawing straight lines. So what we're saying here is, if we had an actual program or if we had a straight edge and we were doing it on graph paper, what we would want to see is, does the line go through the origin and is it a straight line? If it is, which this one would be, if I drew it better, then it is proportional. Okay, guys? So that's all we're looking at in this chapter. And I'm sorry, I said we were coming to the end. We've still got one more lesson. This is 2.5. All right. So hope you guys are all doing well. We'll talk to you soon.